All right, guys, on the second page here is a quick review of synthetic division. The problem we're going to work is going to be 3x cubed minus 17x squared plus 15x minus 25 divided by x plus 5. You still have to keep in mind of those words that we were using, divisor, dividend, quotient, remainder, because I'm going to use those throughout the video. In this case, 3x cubed minus 17x squared plus 15x minus 25 is your dividend. X plus 5 is your divisor. When we do synthetic division, we're actually not going to have to mess with any variables or anything along those lines. We're going to use all the coefficients. Like polynomial long division, you must have all your x's in descending order. In this scenario, we have an x cubed, x squared, x to the first, and of course this minus 25 is really an x to the 0 because it's a constant. So those are all in descending order, and that one's good to go. If you look at the divisor, we have an x to the first, and of course this constant is x to the 0, so they're in descending order, so that is good to go. If you do not have all your x's accounted for, counting from the highest exponent to 0, you'll need to add in a 0 with x, with the number x, with the exponent that you're missing. If you read the opening paragraph, I actually give you an example as well. Also, please note that in your packet, the program LaTeX that I use actually formats synthetic division in a little different way than how I'm going to do it on the video. You can do it either way, to be perfectly honest with you. I don't know why LaTeX formats it this way. I've seen it in a very old textbook this way, but the way I do it is how you'll see it in every textbook, and every math person has done it the way I've seen it, the way I'm going to do it. This is the only way I've seen it. All right, so the first step becomes we need to figure out what all numbers we're going to be using. Well, we're going to look at our dividend, and we have our 3x cubed minus 17x squared plus 15x minus 25. And all we're going to do is we're going to take those coefficients, and we have to keep them in that order. So the coefficient in front of my x cubed is a 3. My coefficient in front of x squared is a negative 17. Always bring the sign with it, but we don't ever write the plus sign because it's understood. So really it was plus 3, minus 17. The next one is plus 15, so that's a positive 15. The next is minus 25, so that is negative 25. You're going to put a line there with the space for you to write. You're going to make a half a box over to the left. In this half a box right here, we are going to put a number. The question is what number? Well, we're going to get that number from our divisor. What we're going to do is we're going to set our divisor equal to 0 and solve. So when I do x plus 5 equals 0, x is negative 5. Therefore, negative 5 right here is going to go inside this box. Now, as you look, that is the number 1. Me kind of explaining. If you see that there are 3 dots in math, that means therefore. So if you see this symbol, that actually means therefore. When I started writing this, because I was typing so much, I kind of clicked into math mode, and I didn't realize I was putting these symbols until I finished reading it, and I wasn't going to go back and change it up for you guys. So, all right, so now let's look at the process. If you look at step 2, that we're at step 2. Step 3 says actually bring down your first term. So we're going to take this 3, and we're going to move it down, and we're going to bring it right here. We then are going to take this negative 5. We're now going to step 4. We're going to take this negative 5. We're going to multiply it by this 3. And whatever result we get, the product we get, we're going to put it right here. So negative 5 times 3 is negative 15. From there, what we're going to do is we go down, we're going to add these two terms. And that's going to be our new number in our last row. So negative 17 plus negative 15 is negative 32. And you can see that on number 5, step 5 of the second page. Then we're just going to repeat the process. We're going to take my 5, negative 5, and I'm going to multiply it by negative 32. We're going to write it underneath the 15, as you see in step 6. So when I do that, I get a 160. Then I take these terms, I add them. When I add them, I get 175. That is step 7. And then we repeat the process all over again. We do negative 5 times 175. So if you look at step 8, you see that I'm doing that there. That gives you negative 875. Of course, then we add these, and that gives you negative 900. Now, I like putting a little box there. That's more just for me. Because when I do this box tells me right here, this is actually my remainder. All of this right here, this 3, this negative 32, and this 175, that is actually reduced a polynomial by 1 degree. So, originally we had a 3x cubed. So if we take 1 away from 3, this becomes 3x squared. So this becomes x squared. This negative 17x squared, we're going to take 1 away from that. So it's going to be minus 32x. And of course, here, this x term, x to the first, if I take 1 away, that becomes my constant, and I'll put my plus sign there. So from synthetic division, we can reduce this polynomial to 3x squared minus 32x plus 175 plus my remainder of negative 900 divided by my divisor, which is x plus 5. So here we have our quotient. We have our quotient right here, my remainder, and of course then that is also my divisor. It's the same terminology, the same format as polynomial long division. This just gives you another option. I like synthetic division, in fact, more than polynomial long division. I have read that synthetic division does not work 100% of the time. Yet in my personal experience, I have never seen a time that it has not worked. I'm going to trust the books because there are people out there smarter than me, but from my personal experience, I have not seen it yet.